Hello students, I am Ravi Shankar Pal from ABES Engineering College Ghaziabad. In today's video lecture, I will discuss about the analysis of algorithm. In this video lecture, I will explain about the time and space complexity of the algorithm. So let's start. First, do you know what is the analysis of algorithm? Basically, analysis of algorithms is in terms of time and space taken to execute any problem. Okay. So first we find a best solution of a problem. If this is the problem, we find the different solution, that is also known as algorithm for this problem. For a single problem, we find out the different algorithm or solution, and we evaluate which one is the best solution or algorithm for this problem. And basically this is evaluated in terms of time and space. Means if a problem or algorithm will take minimum time to execute and minimum space to store, then we say that this algorithm is best. And these are always evaluated in terms of input size of the problem. Input size of the problem. Okay. So we will take with an example. First, we know how many types of algorithm are there. There are basically two types of algorithm. First one is iterative algorithm, and second one is recursive algorithm. In iterative algorithm, we have loops. Suppose this is the function and we have a loop for I is equals to 1 to I less than or equal to n, I plus plus like this. And second one loop inside this, that is for I is j is equals to 1 to j is less than or equals to I j plus plus, and then print some statement like my name, that is Ravi, and etc. This is called iterative algorithm. Here we use loops like for loop or what loop inside the algorithm. And second one is recursive algorithm. In recursive algorithm, basically we use recursive function, like if there is a function a and if some base conditions, and then again if this function call itself, then this is called recursive algorithm. Here a function is a and input size is n, then this function call itself here two times, and this time input size is reduced to n by 2 times. So this is called recursive algorithm and recursive problem. So we will solve these problems one by one. So first take one example of iterative algorithm, how to find out the time complexity of iterative algorithm. We take an example. Suppose we will find the average of n numbers, then we have function average array, and we pass input size. Time complexity is always evaluated in terms of input size. This is input size. Okay. And if this is sum is equals to 0 for I is equals to 0, I less than or equals to n, I plus plus sum is equals to sum plus a I, average is equals to sum divided by n. So how to find the time complexity of these programming statement or algorithms? This is a function of input size n. So if the time complexity of this function is Tn, then how to find out this time complexity in terms of input size? Except, as already told, that except iterative and recursive function, all statement or syntax have time complexity that is constant, and this loop will execute n times. Okay, so basically you can also explain about time complexity, that is it count the count the number of primitive operations number of primitive operations, that is steps, as a function of input size input size. So basically we will count how many times this loop will execute. This loop will execute n times, so this statement will execute n times. So, and this is the basically time complexity. It depends on basically times of this loop will execute. We will take, and all other statement will take complexity constant. Okay, so basically time complexity depends on totally iterative and recursive function, how many times, yeah, how many steps these primitive operation will execute. Basically, what is primitive operations? You know about primitive operations. Primitive operations of a program or algorithm is basically, in computer there are two types of operations. First one is called arithmetic operations, and second one is called data transfer, like data transfer. Arithmetic operation like plus, minus, multiplication, division, modulus, etc. And data transfer is from register to memory, memory to register, register to register, like that. These are called the primitive operations. What is algorithm? What is time complexity? Time complexity is basically count the number of primitive operations or steps as a function of input size. We will take another example of iterative operations. If there is a function, what will be the size n, and if we have two loops, first we'll take single loop and it will execute I is equals to I plus 2, or I divide by 2, and we print some statement, whatever statement, doesn't matter. What will be the time complexity? The time complexity of this function. This is the total input size. The time complexity of this function is depends on the number of steps this line will be executed. Yeah, this syntax. This syntax will executed how many times? Basically, this will executed log n times, because every times this will reduce by 2. Okay, so on base 2. Similarly, if this will execute I is equal to y by 2, this is also execute uh, run log n times. So this is the basically iterative time complexity. Now we will discuss about the recursive time complexity. How to evaluate the time complexity for recursive function. The recursive function is look like something. If this is the function of input size n, and there is some base case or anchor or termination case in the function, and then we call recursive function like function n minus 1. This is recursive function, okay, and this will get terminated. So if the time complexity of this recursive function is Tn, and we know that except loop or iterative function and recursive function, all other are time complexity constant. So suppose the time complexity of this is constant and this is recursive function. So the time complexity of this one is Tn minus 1. So we will prepare a recursive function like 1, the time complexity for all statement, that is constant except recursive function. The time complexity of recursive function is that is t n minus 1. So we can solve this recursive function to find the time complexity, and this is called recursive function. How this recursive function will terminate? Basically, the recursive function will be solved by we have 1 plus t n minus 1 by 2. This recursive function will be solved by some substitution methods or another recursive method. We will take example of substitution method. So we will substitute or reduce value of input. That is, if this is equation number 1, then we will put n minus 1 in place of n. This will be t n minus 1 minus 1, that is 1 plus t n minus 2. Similarly, if we put t n minus 2 in place of n in equation number 1 only, we will put all values in equation number 1 only. This is 1 plus t, 1 plus t, and what will be the value of tn minus 2? Tn, sorry, t n minus 2 minus 1, that is equals to 1 plus t n minus 3. Similarly, we can also find out the value of t n minus 3. So this will be 1 plus t n minus 4, like that. Put all these values in equation number 1, so we can find the recursive function like 1 plus. First we will put tn minus 1 value from here, that is 1 plus tn minus 2. This will 2 plus tn minus 2. Now put the value of tn minus 2 from here. This will be 2t, that is 1 1, this is 1 1 plus tn minus 3, tn minus 3, that is 3 plus tn minus 3. Similarly, if we can put this value like, then the pattern will be k plus tn minus k, because this is the times you will reduce the value of input size tn minus 1, then we will get 1 plus. If tn minus 2, you will get 2. If you tn minus 3, then you will get 3. If you repeat this step k times, then it will be n minus k. And when it will terminate if that is tn is equals to, that is tn is equals to tn minus 1 plus 1 when n is greater than 1, and is equals to 1 if n is equal to 1. Okay, so this is called base case or termination case. So when we will put this value tn minus k is equal to, that is if t1 is equals to n minus t n minus k, so n minus k is equals to 1, so k is equals to n minus 1. So put this value here, k is equal to n minus 1 plus tn minus k is equals to, that is t1. Okay, and what will be the value of t1 here if n is equal to 1, that is 1. This will be n minus 1 plus 1, that is n. This will be the time complexity of this recursive function, that is big O of n. Thank you. This is the references. I have taken this data to explain. Thank you for listening.